Alrighty, hey everyone, welcome to part 2 of our episode 4, which is this part is going to go over actually growing plants and seeing them visually appear on your game. Because right now, if you recall in part 1, all we did was just work on planting these seeds, which you see, okay? We go over here and we plant a seed, you see that it gets planted. However, we also want to note that we already planted a ton of seeds right here, which you can see in our plot data sort of table that we have. So in order to actually make these plants appear, we will do so in this video, and we're going to do it on the client, which I discussed earlier in part 1. So if we go to seed service and plot service, let's open both of these up, and you'll notice that after we finish doing our plant effect, let's go ahead and make a function or call a function called updatePlot. So we can say PlotService.updatePlot, and we want to add in our player, an action called seedPlanted, as well as the item key, which is our unique identifier that we had. And because we created that function, we also need to create it in here. So let's collapse all of these things that we don't necessarily need and work on our new function. So we can say function service.updatePlot, which we passed in our player. We also passed in the action, which is a string, and the sort of data, any, which is the table that we passed in containing the key. So we can say, okay, we need to get our player data, so cached modules. Ooh, I forgot to require it. So we'll say local cached modules, script.parent.server.cached modules. We can say cached modules.cache.dataService. And if player data, if the action is equal to seed planted, right, which is right here, then we're going to check for the item key that we passed in. So local item key, which is a string, is equal to data.itemKey. And if the item key is there, then we're going to check for the new item data and our plot data. So you can say player data.plot data item key, which if you recall, we already added it in right here. So if we go back over here, and say if new item data, then we're going to update the plot with the new item. So we're going to create a new function up here called createServerModel, which we want to accept a player, a key, as well as data. And we're going to say service.createServerModel, our player, item key, and the new item data. And let's say like, okay, we want a new action here as well. We can say, okay, if action equals fruit harvested, then we're going to do something with this. But this is going to be done in the episode 5, the next episode, and not this one. But we're just planning for the future. And yeah. So since we called this function right here, we need to actually work on that function now. So we're going to want to get the data service. So cached modules like cache.dataService, and we're going to get our player data. Oops, data service.get data. We're going to say local plot data equals player data.plot data. Local save data is equal to our save data, like so. And now we can say local true name is equal to key splits, which you notice that the identifier is something like this. So we're going to split it by the colon, and we're going to get the first value in the array, which is caret. And that's going to be our true name. We're going to say, okay, local corresponding folder equals assets. So we need to get the assets folder. Like so. And then down here, we can say assets.plants, not plant effect, find first child true name. And okay, if we found the corresponding folder and there's save data and there's seed data, which we're gonna need to reference as well. So we're gonna get our modules. I'm gonna say local seed data module. That's seed data. And we can also say right here, we can say local seed data is equal to seed data module.getData, our true name, .seed. Because we notice that the name of the folder is called seed and not carrot. So we need to concatenate that with seed as well. So, and seed data, then we're going to clone the server model, which is this model right here in our carrot. So we can say equals corresponding folder.serverModel clone. And we're going to name the server model our key. And we're also going to set some attributes like the owner of this plant, which is our user ID. And we're going to set the attribute of the plot that's on. So we're going to say player.name, like so. So the name of the plot. And now in our plot service, we're going to need to create some new folders in here. So the first thing we want to create is something called ServerModel config. Another folder we're going to make is fruit config template, like so. So the best way I can explain this is that although we have our save data up here, which already contains things like our growth percentage, things like that, our client can't directly access these values since these are saved or accessible only by the server. So in order for our server to actually view these values and make them only readable so we can grow our trees on the client, we need to create servers or folders that replicate the values. So in our server model config, we can add in things like fruits, which matches this right here. Oh, I also forgot earlier in part 1 to actually add in our fruits array to this. We can say fruits is equal to fruit array, and that should be good. Alright, going back to this, we want to sort of make this similar to everything that we saved. So we'll have a fruits folder and we'll have a bunch of values. So we'll have int value, and we'll call this int value growth percentage, like so. Or no, we want this to be a number value, because number values can be stored as decimals, like so. However, int values can only be stored as whole numbers, which you see if we save 15.5, you see it has an error, unable to cast string to N64. So it needs to be a whole number, like so. So with that in mind, for growth percentage, we can make it a decimal or a number value. And for date planted, this is going to be a whole number. And last growth increment is also going to be a whole number, like so. And now for a fruit config template, you'll notice that we have all of our values like CanHarvest, last harvest, things like that. So we're going to replicate those too. So CanHarvest, which is a bool value, last harvest, which is an int value, and the mutations, which is a string value, like so. And that should be good. So now if we head back to our plot service, we can actually replicate our save data right here. So we can go right here and say local server config is equal to our script.serverModel config clone, and then we can name it server configuration. And then we're going to make a comment assigning configuration values for easy viewing on client/server. So server config.datePlanted.value equals data.datePlanted. Server config.growthPercentage.value equals data.growthPercentage. Server config.last growth increment, and things like that. Like so. And we also want to loop through our data.fruits, which is right here. So the fruits in the plant. So for index number, which is our array right here, comma fruit data, which is a table, and data.fruits do. We can say local fruit config equals script.fruit config template clone fruit config.name equals toString index, and we just want to set the values like we did up here. So we can say last harvest value, and then fruit config.mutations.value is equal to our fruit data.mutations. We're going to want to parent this to our server config.fruits. Now, one thing I want to note is that even though we've changed or replicated our values here, what happens when these values get changed? We want a way for the server to actually update these values in our save data as well. So let's make a comment here called updating folder, and then actual plot data, because the plot data is the only thing that actually saves. These values here don't actually save, they're just replicating for easy viewing, which is noted up here. And we can say for underscore, comma v, and fruit config, get children do. If v isn't a folder, then we can say, okay, when it gets changed, we can say if save data.fruits index v.name is not no, then we're going to just update the data is equal to v.value. And similarly, since we only updated our fruit configs, we also want to update the server config to the save data. So let's see what we want. We can say all the way down here, once we get out of this sort of loop right here, we can also update to the folder. Update the server config folder. Like so. So we can say for underscore comma v and server config, get children do. If v isn't a folder, then v.changed. Connect function. And we can say if save data v.name is not nil, then save data v.name is equal to v.value. So that way it replicates it to our save data, which is the thing that actually saves. Like so. And of course, we're going to want to parent the server config to the actual server model, like so. And let's see what else we want to do for this. Let's see. All right. So now that we parented the server config to the server model, we're going to want to create a folder in our map. And we want the folder to be called planted seeds. And we're going to create two new folders in here called client and server. So obviously server models are going to be parented to the server, and client models are going to be parented to the client. However, each model in here, they're going to have the same name. So we can say, but first off, we're going to want to actually position the server model to the location that we saved. And you remember that we saved this in a unique way, where if you recall over here, we saved it in a way that it's relative to the plot. So that way, if you spawn on a different plot than the one you previously planted on, it'll still be in the same position. So we're going to want to deserialize the CFrame. So we're going to unpack our data.location. But you recall the data is just our save data that we inputted right here. And we're going to want to say deserialize CFrame is equal to CFrame.new.position. And we're going to want to convert it to the global/world CFrame. So we're going to say service.getPlot player.reference point.cframe to world space and our deserialized CFrame. And now we're going to just want to position the server model to that CFrame. And we're going to want to finally parent it to the workspace, like so. And that should be good for our createServerModel function. And if you recall already, we already created it down here. So as of right now, this function only works, or your plant models only work whenever you plant a new seed. We want the plants to work always. So for example, whenever you join the game, you also want your seeds to load. So for that to work, we can go over here and we can say loading plots. Local plot data equals cache modules.cache.data service. And we want to get data, our plot data, Let's put this in a separate thread so it doesn't yield. We can say for key string, comma data any, and plot data do, and we're just going to want to create the server model like so, and pass in our events. And over here, let's see, that should be good. And right here, we're just going to want to warn our plot data. So we're going to say warn player plot data like so. And now if we play the game, let's see, it errored. Oh, once again, Roblox case sensitivity. Always remember to make it uppercase like so. And let's see what else we have. Fruit data and data.fruits. Oh yeah, because remember previously we just had to add this into our array. So what we can do is we can just wipe our player data right now. So we can say make it _5, and we can plant some new seeds. So if we go over here and we plant some seeds. Oh, we forgot to actually do .getData on our data service. So we're going to need to say .getData like so, and it should work. So if you go over here, you'll see that we have one seed planted. And if you open up our map and our server, you can see that our carrot is planted right here. And you can see that the height is on point and it's directly on the surface. And if you plant a new one, you see that nice. They're all planted like so. And if you open the folder, you see that, okay, we have plants, CanHarvest, false, our date planted, our growth percentage, and things like that. So now that's all great. That's great and all, but now we want to actually replicate these server carrots to the client and make them actually look like they're growing. So let's go ahead and go over to our starter player scripts. And let's make a folder called, let's see, how do we want this to be called? We can call this CropReplicator. And let's create a local script inside of here called main. And obviously this is going to handle all of our crop replication from the server to the client. So we can say, we can reference our players because we're going to need to reference a lot of things here. Tween service for actually animating the crops. And we're going to get our player, get the assets, get our modules, which, since this is our crop replicator, we need the seed module. And then we'll need our plants folder in the assets folder. We also want to get our world. And we want our planted seeds folder. Map.plant seeds. We're gonna want the client folder and the server folder. Server. And we're gonna want to wait constantly until the player actually has their data loaded in. And we're gonna want to wait maybe 1 second before actually loading in all of our plants. So now that's done, we're going to replicate our server parts to the client. So we're going to make two functions in here. We're going to have one called child added, and we're going to have another one called child removed. So if you recall, whenever we plant our seeds in, like so, it creates a new model to the planted seeds.server folder. So we can actually check whenever those models are added in. So we can say, okay, server folder.child added, connect function child, and we can put this in a separate thread and do child added, child remove, connect child removed. Or if there's already children in the folder when we load it in the game, we can check for that too. Like so. And in our child removed, this is for, like, let's say the player leaves the game or something like that, and we want to actually clean up all of the plants. We can say, okay, local identifier equals child.name, which is our key. If you recall, it's going to look something like that. We can say local found client model equals client folder find first child identifier. If found client model, then we just want to destroy it. And of course, in our plot service, we want to make it to where the player's plot is actually removed when they leave the game. So in here, we can say clearing plots. And we can say for underscore, comma plant model, and workspace.world.map.plantedseeds.server, get children do. If plant get attribute owner equals our player user ID, then we'll just remove the plant or destroy it. Which is why we set attributes up here, so we can know who owns the plant. And yeah, that should be good. So in our local script, you'll see, well, in our server script, you'll see that we destroyed the server plant. And here we're checking when it's destroyed and removing the client model from the client folder. So now that that's out and good, we're going to want to work on when the server model is actually added. So we're going to say local identifier equals child.name. If not client folder find first child identifier, then we want to clone a new client model. So local true name equals identifier split by the colon, and we want to do 1. Local found model equals plants folder find first child true name. If we found the model, we're going to want to clone it. Equals found model.client model, which if you look in here, client model clone. And we're going to name the client model our identifier. And we're going to want to position it or pivot it to the server model, like so. And let me call this child, not whatever I just called it. And then we're going to just want to default the visibility of the parts, because we don't want all of the parts to be visible the moment the player joins the game, because we want it to actually be simulated by growing. So we're going to say client model set attribute fully grown, comma false. And we're going to want to loop through all of our client models. And we're going to want to see if there's a property in here called, or property in here called transparency, like so. And we're going to say, okay, if there's a property, then we're going to want to set the transparency to 0 and set the attributes of all of the parts in here. So you see in here we have appear percentage, which if you recall from the introduction, handles which parts we want to appear based on the growth percentage that they're at. So we'll say vset attribute original size, v.size, vset attribute original CFrame or position. And we're going to want to make a new attribute called as tweened and set it to false. And we're going to want to just set all of these sizes to 0.01. And we're going to want to also set the CFrame to the middle of the client model, so that way the animation can be smoother when we animate it. And now that we've looped through all of that, we can parent the model to our client model. Oops, not in here, right here. Client model.parent is equal to our client folder, like so. And if we quickly play the game, let's see what happened here. Oh, parent, I spelled it wrong. There we go. And now over here, you'll see that if we go to our garden and we open up the client, like so, you'll see that our carrots are right here. And you see fully grown is set to false, but let's say, okay, let's just make it visible to see. And we also want the size to be like 1, so we actually can see it. So you see that, okay, it's there and stuff, but we just haven't tweened it out yet. So now let's work on the tweening. So we can say, make a comment here called handling client visuals, are growing and etc, harvestable and things like that. Server config equals child, find first child, server configuration. And if you recall, our child here is a server model. So it's going to have a folder in there called, if I go up here, called server configuration. So if we go back over here, we can say, okay, if server config, then handling our growth percentage right here. So we can say local growth percentage, server config, find for child, or wait for child growth percentage, because we know it's going to be there. And we can also make it to where detect it when we're changing it, like so. Now this is good and all, but we also want to make a function to detect when it's updated. So up here we can make a function called GrowthPercentageUpdated. And in our growth percentage function, we want to have two parameters, which is our client model and the new growth percentage value, like so. And going down here, we can update it. So growth percentage updated, our client model, and the percentage value. Or if we first load in the game and it hasn't changed yet, we're just gonna update it normally. Dot value. And let's see. Up here, now we can write our growth percentage updated function. So let's put this all in a separate thread, like so. And we can loop through all of our client model objects. So notice over here, we added attributes like is_tween and things like that. So we're going to check for those attributes, because those are going to be the attributes that we want to actually animate. So appear percentage, and we want to get the original CFrame. So let's make another thread so it doesn't yield. So if is_tweened is not null, so if we have a value called is_tweened or an attribute called is_tweened, and the original size is there, and we have an original percentage or appear percentage, we can say if is_tweened equals false, then if our new growth value is greater than or equal to the appear percentage, then we're going to want to fade it in. So we're going to want to say is_tweened, comma true, set the attribute, and we're going to want to tween it. So we're going to animate the part now. Size equal to original size. And we're going to want to set the CFrame to the original CFrame. Transparency is 0, and we want to play it, like so. And over here, for it to have sort of like a multi-fade in effect, we're going to want to add in a test.wait 0.05. And after everything's sort of tweened in, we're going to say, okay, if our growth percentage is equal to or greater than or equal to 100, then we're going to want to set our fully grown attribute to true. So the reason for this is because this is going to be used later in this part 2 episode to actually enable the harvest proximity prompt. So yeah. And let's go over here. So this should work now. However, we haven't implemented the actual growing system yet, which we're going to do right now in our plant service or plot service. So we're going to create an init function, which is going to run the moment the game starts. Because if you recall, we scripted it in our server to init the modules, if there's an init function there. And we're going to make a comment called growing seeds / making fruits, and this will also include offline growing, as this system is reliant on the date planted data, or the date planted value, which if you recall is this right here. So we can say test.spawn, and we want to wait every 1 second. So for _cropped in model, we're going to want to loop through every single planted server seed in the game. And we're going to want to check the plot number as well as the owner. And we're going to want to get the player as well. Plot number. We're going to say, okay, if there's no player, then we'll just continue on with the next crop. But if there is a player, we're going to want to get the player data. So local player data equals data service, which we're going to want to get up here. I'm going to want to get it right here. like so. And here, we're going to want to get the player data. And we're going to want to get the growth percentage of, well, we want to get all of the values of these crops. So we're going to say server config, crop.server configuration, or we want to find the server configuration at least. And if server config, then we're going to want to get the growth percentage. We're going to want to get the last growth increment. As well as the date planted. And if you recall, these are all values, so we have to say .value whenever we reference them. So we're going to get our seed name is equal to crop.nameSplits, because if you recall, it's using the identifier formula that we did, .seed. We're going to say local found seed equals our seed data module.getData, the seed name. So we can say, also we want to get the harvest interval. So found seed.harvest interval.value. So the duration between harvests. So if plot number and owner and found seed, then we're going to want to grow these plants. So we're going to say if growth percentage.value is greater than or equal to 100, then we're going to work on the harvesting part, the harvesting seeds part. Otherwise, we're just going to work on the normal growing part of the plants. And right here, we'll just say if growth percentage, then we're just going to say else, like so. Now we're going to say local growth time is equal to found seed.growth time, so how long it takes for the seed to actually grow. So if we go over here, put a caret, growth time, we see that we have 5 seconds for it to grow. So we can say if os.time minus the last growth increment of value is greater than 1. So if 1 second has passed before we can grow again, then we're going to increment. So we can say last growth increment of value, os.time, growth percentage.value is going to be reliant on the date planted value that we have. So os.time minus date planted.value divided by our growth time, like so. And we're going to want to multiply this by 100 because our growth percentage scale is on a scale from 0 to 100. 0, 100, like so. And that should be our offline and online growing system. Let's see. Yep, that should be good. So we go over here and we play the game. We teleport to our garden. Let's see. It's not working. Let's see. Plot service. Whoops. So right here in plot service, this is just our plot number. We need to actually get the owner by user ID. So now if we play the game, let's see. And you notice that our crops are growing. And if we go over here to our seeds, and we go ahead and just plant one, you notice that it's growing based on the growth time. Like so. And yeah. Now that the growing system done, let's prepare for the actual harvesting part of the system that we have. So you'll notice in the crops model or the plants model that I have for y'all, in the server model, we have fruit prompts in here, which if you move both of these to the workspace, you'll notice that the server model fruit prompts are aligned with where the fruits are on the actual model. And you notice that the client model has fruit 1, fruit 2, and across the board, the client model, not for if it's multi-harvest or not multi-harvest, if it's a single harvest, then there's going to be no fruit 1, fruit 2. However, if it's a multi-harvest, you see fruit 1, fruit 2, fruit 3, fruit 4, and the same with blueberries. So, knowing that, let's start with our harvest system. So in PlotService, you'll recall that we sort of left a spot for harvesting seeds. So right here we can say if found seed .multiharvest.value then. Otherwise, this is just a single harvest seed or a crop, like so. So right here, we can say local folder equals crop or server configuration dot fruits 1, because it only has 1 fruit for a single harvest fruit. And we can say if folder dot CanHarvest dot value, then continue. So it's just gonna skip that because it's the CanHarvest already set to true. Otherwise, we'll just set this to true, like so. Now for this one, this means that it has multiple fruits that can be harvested. So let's go through another thread. I'm going to say for underscore comma fruit and server config dot fruits get children do. We're going to say local last harvest equals fruit dot last harvest. Local can harvest equals fruit dot can harvest. And let's just get the mutations for the future. So we can say, okay, if the time between our last harvest is greater than or equal to the harvest interval, which is the cooldown between harvest, then we want to set the harvest to true. Otherwise, we'll set the can harvest to false, like so. And now these lines of code will only work if our growth percentage is 100. And it accounts for multi-harvesting or just single harvest, like so. Now that that's done, we also want to work on having the prompts, the proximity prompts, because right now you'll notice that if we play the game, let me go over here to garden, you'll see that yes, the can harvest value set to true, but there's no prompts indicating that yet. So in order for that to work, we can go over here to PlotService, and whenever we do our create server model, we can also check for the proximity prompts and create them. So right here we can say creating proximity prompts, and over here in our plot service, let's create a mock or a template proximity prompt in here. So we're going to call this prompt harvest prompt, like so. And in here, we're just going to want to make the whole duration maybe 0.5 seconds, like so. Because we don't want the player to automatically be able to collect them or immediately collect them to press E, just in case they didn't mean to actually collect it and they lose all their mutations and things like that. So we're going to also want to account for multi-harvest. So we can say if seedData.multi-harvest then, otherwise it's a single harvest. So for single harvest, we're going to just want to clone the prompt to the primary part. We're going to want to disable it for now because we don't know if it's actually fully grown yet. And we're going to want to parent this to our ServerModel.primary part, like so. And right here, if it's a multi-harvest, we're going to go through, loop through our fruits prompt, which if you recall in the model is right here, and it corresponds with all these fruits right here. So fruit prompts, ServerModel, find first child, fruit prompts. At fruit prompts then, we're going to loop through all of them. So we're going to loop through all of our server config.fruits. And we're going to check for the corresponding part. So if we found the part, then we're going to clone the harvest prompt, like so. And instead of cloning it to the primary part, we're just going to want to clone this to the corresponding part of the fruit, like so. And that should be good. So now, if you play the game, and you go over here, even though the prompts don't show yet, if you open up the server and you go to primary part, you'll see that it has a harvest prompt. If you enable it, first off, we need to actually go to harvest prompt and disable requires line of sight. And that should be good. So now if you play the game and you teleport over to your garden, and you open up the server, let's say this carrot right here. If you enable it and you walk over there, you'll see that, okay, it has a harvesting. Now obviously, you won't be able to do this in the actual game. And obviously exploiters can do this, but we're gonna have checks on the server to make sure that the fruit can actually be harvested by you. So I just wanted to display that so we actually can see the prompt working. So now that's done, on the client, we can actually enable these prompts. So in here, you'll notice that we handled our growth percentage right here, but we can also handle our harvesting visual. So you can say handling harvest visual. So local seed data equals our datum, our seed module. Get data true name .seed. So if seed data, then we're gonna look through our fruits folder, like so. And we're gonna want to loop through all of these fruits. Get children do. And we're gonna say, okay, if the seed data multi-harvest is set to true, and there we go, like that. So essentially what we're doing is we're looping through all of our fruits that are available. And we're saying, okay, if the seed or the crop itself is multi-harvestable, then we're going to do something different than if it's not. So if it's not multi-harvestable, we're going to create a new object value. In here, and we're going to call this corresponding adornee. And I'll explain what that means in a second. Then object value is equal to the client model, and we're going to want to parent this to the child.primary part, wait for child to harvest prompt, like so. So essentially what we're doing is whenever the harvest prompt is shown, we're going to want to make a highlight on the corresponding fruit so that we know which fruit we're harvesting. Because sometimes if you have too many fruits, you won't know which fruit is which. So the corresponding adornee is simply for highlighting parts that you're trying to harvest. And if we're multi-harvest, we're going to say found model, client model find first child fruit underscore the v.name, the fruit name. We're going to say, okay, if we found the model, then we're just going to create the corresponding adornee, like so. And we're going to say found model instead of the client model, and then we're going to want to parent this to the fruit prompts. To string v.name .harvest prompt, like so. And that should be good. So this is simply just handling our highlight visual. And now over here, we can work on the actual enabling the harvest prompt. So handling visibility of prompts. So local CanHarvest equals v find first child CanHarvest. So if CanHarvest is not nil, then we're going to detect when it's changed and we're going to update it. Or if it's already harvestable, we're also going to want to update it accordingly. So up here, we're gonna make a new function similar to our update growth percentage called harvestableChanged. And we're gonna want to get our server model as well as the client model, the fruit number, which is a string, whether it's harvestable or not, which is a boolean, and the multi-harvest sort of value in here, which is also going to be a boolean. And then now we can put this all in the test.spawn in a different thread. We can say, okay, if it's not fully grown yet, if client model get attribute fully grown equals false, then we're going to wait until it's fully grown. But this is only going to be valid if the plant's harvestable is set to true, or this harvestable boolean here is true. So if it's harvestable, then we're going to go over here and we're going to say, we're going to wait until the fruit finishes animating. Like so. And we're going to say, okay, if, and right here we can say if we can enable the prompt. So test.spawn function, if multi-harvest, then our ServerModel.fruitPrompts fruit number .harvestPrompt.enabled is equal to true. Otherwise, we're just going to want to say we're going to want to enable the prompt in the primary parts. HarvestPrompt.enabled is equal to true. Now, in here, if it's not harvestable, we're going to say else. And we're going to want to just disable the prompt. Like so. I'm going to say test.spawn function. If multi-harvest, then, so we're just going to copy and paste all of this. And we're just going to want to disable it like so. Alright, now that that's good, we also want to tween the fruits in and make them animatable, make them appear. So, in order to do that, we're going to go down here after our first thread, and we're going to make a new one. And we're going to want to loop through all of our client model. And of course, it's going to still sort of have the same thing, so we can say is tweened. Vget attribute is tweened. Original size. Our original CFrame. And we're going to say if isTweened is not nil and there's the original size, then. So we're going to say, okay, if it's already tweened, then we're just going to continue on with everything else. And a vget attribute fruit number, which if you recall, the fruit number is corresponding to this right here, each of the fruits. So if it's equal to the fruit number we're trying to make visible, then we're going to continue on with the script. Let's set this to true, and we're going to want to tween. So size is equal to original size, our CFrame. Original CFrame, our transparency is equal to 0, and we're just going to play it. And similarly, we're going to tween it also for when we're going to get rid of it. So over here in our test.spawn, we're going to do the same thing, but instead of setting isTween to true, we're setting this to false, and we're tweening the size to 0.01. And the original Z-frame to the middle of our primary part. And that should be good for our harvestable_changed function. And now if we scroll down here, we're going to actually need to call the change function. So we want to get our child, which is a server model, a client model, as well as the fruit number, CanHarvest.value, and seeddata.multiharvest.value. And similarly, we're going to want to do the same thing right here. And we can now collapse all of these to make it easier to read. And if you play the game right here, and we go to our garden, you notice that the proximity prompts get enabled, like so, which is good. Now if you plant the seed right here, you'll notice that the prompt isn't enabled yet, but as the plant grows, oops, let's see what happened here. Okay, so the issue with this was because in our harvestable_changed function, you notice that we did, okay, if harvestable is true, then, and we're saying, okay, if it's not fully grown yet, then we're gonna want to do everything in here. However, we didn't account for the fact that if fully grown is already set to true. So in here, instead of saying this, we can go ahead and remove all of this right here. Or instead we can remove everything right here. We can say, okay, if fully grown is set to false, then we're going to wait to yield the script until it's set to true. And after that, outside of this function here, we will run the code that we had. So now, if we play the game and we go over here to our carrot seeds, we buy some. You notice that if we plant it and we wait a little bit until it finishes growing, you notice that the prompt is set to true. And you'll be able to see the prompt. Let's go ahead and remove this print statement right here. So the final thing we'll want to do, well, one of the final things we want to do is add in the sort of highlight on the plant. So in order to do that, let's go over here to PromptClient and create a new highlight in here called Harvest Highlight. So this is going to be sort of our template that we're going to want to use. And we're going to make this sort of a yellowish color. And make it 0.5, and we're going to make this, yep, that should be good. And in our prompt client, we're going to use ProximityPromptService. So we're going to say, okay, prompt shown, connect function, our prompt. And we're going to detect also when the prompt gets hidden. Like so. And here we're going to say, okay, if the prompt name is equal to harvest prompt, then we're going to want to find the corresponding model, which is the object value that we created in here, called corresponding adorning. So proximity prompt find for child corresponding adorning, which you remember we parented to the prompt. And we can say if corresponding model, then script.highlight.adorning is equal to our model.value. Similarly, right here, we can say if prompt.name equals harvest prompt, then we're just going to want to set the adorning to no. So the highlight stops highlighting anything that it's highlighting. So now, if we play the game and we go over here to our garden, oh, let's see what happens. Right here. We set ProximityPromptService instead of the prompt. There we go, that should be good. And if we play the game and wait for our things to load in, notice that whenever we hover over a crop, you notice that the highlight appears, like so. And that's exactly what we want. And if we go ahead and plant another seed, like so, wait for it to grow, you see that the prompt also works. And now the final thing I want to do is show y'all how to add in the new seeds that we have. Let's go ahead and exit out of all of these scripts right here. And you recall that we have 4 different plants called blueberry, cacao, carrot, and tomato. And in here, in order to replicate those, we can duplicate these things right here. For example, we want a cacao seed, for example. Remember that in order to make a new seed, you'll want the name of this plant plus seed. And over here, we want the display name, so we want to edit all of these. As well as the cost, maybe 100 or something. And we want the growth time, let's make it like 20 seconds. And the harvest count, obviously in our cacao seed, you'll see that we have 3 different fruits, or 4 different fruits right here. So we're going to want our harvest count to be 4 and multi-harvest to be set to true. And for our seed prefix, we want this to be called cacao, and that should be good. As well as that, we also want the seed data to be updated. So we want the order to have cacao seed in as well as for any new seeds that you add. And we're going to duplicate the seed and name it cacao seed and change the color a little bit to maybe like a brownish color. And that should be good. So let's look this up once again. You'll see that, okay, we have carrot seed, and carrot seed in there as well. And that should be good. So now if you play the game, and we go over here to our seeds, you see that we have a cacao seed in stock now. And if we buy it, it'll be replicated to our backpack, and we can now plant it, like so. Let's go ahead and plant the seed. And you'll see that the seeds start slowly getting grown with animations. And I also want to note for y'all to remember that the only way that these can grow is for the attribute of a pure percentage to be an attribute in all of the parts that you want to be grown. And now you see that all of the harvestable things are there. So yeah, that's gonna wrap up part 2 of this sort of 2-part episode. So once again, I just want to reiterate over the things that we did today. So the first thing that we did is that we created a new folder in map called client and server, which on the client we handle the actual seed growing part and the replication of the seeds. And on the server, we create a mock part of the seeds because we don't want there to be too much strain of actually growing the seeds visually on the server. So that's why we do that. And also in here, we inventory service. We added remove item and things like that. But mainly in this video, we focused on plot service as well as seed tool visual right here. Or no, we didn't focus on that one. CropReplicator and our PromptClient. So, going through this again. We created a server model whenever the player loads in the game or whenever they plant a new seed. And the server model has, if you go over here to your assets, it has fruit prompts, which is where all of the proximity prompts are going to be, and a primary part, which is the same size as the client model. So we can use them interchangeably if we want to. So in here, we get the seed name, the seed data, and we clone the server model and name it towards the key identifier, and we give it attributes. And once again here, we're adding or assigning our configuration values to be able to be viewed by the client and server. Because our client can't actually view our plot data that we're saving, so we need to do it this way. And also we need to update our save data whenever these values get changed. And right here, we added or created, cloned our proximity prompts based on if there's a single harvest or multi-harvest. And here we just updated our server config folder to match our data that we're actually saving. And we deserialized our CFrame to make it relative to the plot that we spawned in. And here we actually loaded in the plot and then we destroyed the plot whenever the player leaves. And here's where we handle our growing, which in here, this is where we harvest our seeds right here. CanHarvest set to true or false. And this is where we grow our seeds, which is going to be based on the date planted value, which allows for offline growing. And now we're in main folder. This is where we actually updated or replicated our crops. So we created a child remove function and we destroyed our client if the server model gets removed. And here we just cloned the client model. We defaulted the values and we detected when the growth percentage changed. and then we updated it so the plant can actually grow right here. And we also added an adornee, which once again, it's for highlighting the crops or the plants that can be harvested or not. And here, this is where we handle the visibility of the prompts. This handles the highlighting of those prompts. So yeah, that pretty much wraps up this part 2 video. Once again, if you load into the game, you see that all of your plants slowly get loaded in, as well as the harvesting things. And yeah, that's pretty much gonna wrap up this video. There were a lot of complex things talked about in this video, which I can understand. So if you have any questions or suggestions, please leave them in the comment section or in the Discord server. And yeah, thanks for watching part 2 of episode 4, and see y'all in episode 5.